Okay, this question is a little bit more work. It's an application of Hess's law, if you remember back from General Chemistry 1. What you do is you can take these energies, these free energies that are given in the table. You can do this with delta H's and you can do this with delta S's, and you can calculate the different quantities. Now, you have to memorize these formulas. So I have to figure out what the formula for delta G of the reaction is based on these values given in the table. This is how I memorize it. I remember that it's going to be products minus reactants. So it's going to be delta G formation of the products minus delta G formation of the reactants. Now, there's a little bit more to it than that. And so I remember, okay, it's going to be products minus reactants. I'm going to multiply them by their stoichiometric coefficients. That's the N. And I'm going to add up both sides. And so that's how I memorize this equation. And so you're going to need to memorize this one for the same one for the delta G, for delta H, and for S as well. Okay, so the rest is just kind of looking at the table and putting it together. So delta G naught for the reaction equals 1, because that's the stoichiometric coefficient in front of H2CO3 aqueous. And so I'm going to look on the table. I'm going to get that value. I get negative 623.10 kilojoules per mole, and I'm going to subtract that from the reactant side. So 1 times, and now here's the one for CO2, negative 394.39 kilojoules per mole. I'm going to add that together with the H2O liquid, negative 237.14 kilojoules per mole. I usually then add up both brackets separately, so I get negative 623.10 kilojoules per mole minus negative 631.53 kilojoules per mole. Now, subtracting a negative number is just like adding a positive number. And so I'm going to add it, and I get 8.43 kilojoules per mole. And so the question asks us, is it spontaneous or non-spontaneous? And delta G is positive, so it's non-spontaneous under these standard conditions. Okay.